So, let's go. Enough talk, let's start here. Number 10. Glee 667cc, the triple star trap. The standard law of physics and planetary formation tells us a very comforting, simple story. For a planet to have a stable, safe environment for life, it needs to orbit a single, calm, yellow sun, just like ours does, in the constellation of Scorpius. This world exists in a triple star system. If you stood on its surface, your reality would look quite different. You would look up into the sky and see a faint reddish primary sun, while two other stars would shine in the daytime sky, looking as bright as full moons at night. Even so, astrophysics suggests this world could support life. Gliese 667c is about 3.8 times more massive than Earth, which gives it a much stronger gravitational pull. This allows it to hold onto a thick, protective atmosphere. This blanket of gas can trap heat and distribute it across the globe, keeping the temperature at a very steady 86 degrees Fahrenheit. However, the challenge here is that the planet's primary star is a red dwarf. These stars are known for sudden, violent flares of radiation and energy that are 1,000 times stronger than anything our sun produces. To survive in this environment, life would need to be incredibly resilient, adapted to withstand both the intense radiation and atmospheric pressure that feels like being several kilometers deep under Earth's oceans. It is a high-gravity world constantly bathed in deep red light. 9. Kepler 452b, the crushing heavy world. There is a common theory in planetary defense that for life to survive on a small planet, you need a massive gas giant, like our Jupiter, sitting further out. Jupiter acts as a gravitational vacuum cleaner, pulling in comets and asteroids so they do not strike the smaller inner planets. Kepler 452b challenges this assumption. Often called Earth 2.0, this world is 1,800 light-years away in the constellation of Cygnus. It orbits a sun-like star every 384 days, much like we do. But Kepler 452b is alone in its solar system. It has no Jupiter to protect it. Interestingly, supercomputer simulations show that a system without a Jupiter can actually suffer 3.5 times fewer asteroid collisions on its inner planets. The most difficult part of living on this planet would be its size. It is a super-Earth, about 60% larger than our world, and 5 times more massive. Gravity here is twice as strong as what we're used to. If you tried to walk on the surface, your heart would have to work twice as hard to pump blood to your brain, and you would instantly weigh twice as much as you do right now. Because its aging star is getting brighter and hotter, the planet is also receiving intense thermal radiation. This could lead to a runaway greenhouse effect, where heat is trapped so effectively that it slowly roasts the surface under a thick, choking blanket of gas. 8. Kepler 62f, the drowning world. Standard planetary geology suggests that for a stable climate, a planet needs a balance of land and water. Continents help regulate the carbon cycle and drive weather patterns. On Earth, land provided the environment for fire and technology to develop. Kepler 62f is different. Located 1,200 light-years away, this planet is 2.6 times more massive than Earth. Our best simulations suggest it is a true water world, covered entirely by a globally churning ocean with no continents at all. This is a world with no shorelines, just an endless abyss of dark water. This planet is likely tidally locked, meaning one side always faces its star, while the other stays in darkness. However, the planet also has a lean, or an axial tilt. This lean causes the planet to have seasons that drag boiling ocean currents from the day side into the freezing darkness of the night side. If life exists in these depths, it would have to adapt to crushing pressures and an environment where the sun never moves and the land never appears. 7. TRAPPIST-1e, the claustrophobic purgatory. In our solar system, planets are separated by millions of miles of empty space. These vast distances prevent the planets from pulling on each other too much, keeping the neighborhood peaceful. The TRAPPIST-1 system operates on a much smaller scale. Just 39 light-years away, 7 Earth-sized worlds are crowded so close to their star that the entire system could fit inside the orbit of Mercury. TRAPPIST-1e is the 4th planet and might even have an atmosphere rich in oxygen. Living there would mean looking up at a very crowded sky. Because the planets are so close together, your neighbors wouldn't just be tiny dots. They would appear as massive spheres drifting silently overhead, sometimes large enough to blot out sections of the sky. But the star they orbit is a violent red dwarf that regularly fires off radiation flares. Because the planet is tidally locked, life would be caught in a difficult position. One side is a scorched desert, and the other is a frozen wasteland. Any survival would likely be limited to the thin, permanent twilight strip between the two extremes. 6. LHS 1140b, the unblinking eye. We usually assume a planet needs to spin quickly to create day and night cycles, which helps distribute heat. Without that spin, one side would bake while the other froze. LHS 1140b is a super-Earth 48 light-years away that doesn't spin relative to its star. It is tidally locked, with one face always staring at the sun. Most of this massive world is a frozen shell of ice miles thick, but directly under the star's light, the heat is just right to melt a single, massive ocean about 4,000 kilometers wide. From space, the planet looks like a giant, unblinking blue eye staring into the void. This ocean is a small pocket of potential habitability surrounded by endless ice. If life is there, it is confined to this one unmoving patch of water while the rest of the planet remains frozen. 5. The horseshoe twin Earths, the mirror executioner. Gravity usually dictates that a planet must clear its neighborhood. This means a planet's gravity should sweep its path clean of other large objects. If two planets tried to share the same orbit, we'd expect them to eventually collide. In a horseshoe orbit system, two planets of equal mass can actually share the same path. They chase each other around their star, completing a year in the same amount of time. But because one is slightly faster, it eventually catches up to the other every few decades. As they get close, their gravity pulls on one another. Instead of crashing, they engage in a gravitational swap. The inner planet is pushed out, and the outer planet is pulled in. They switch places and start the chase all over again. On a world like this, every 33 years, a twin planet would loom massive in the sky, causing tides 5 times higher than we see on Earth. This isn't just a theory. Saturn's moons Janus and Epimetheus perform this exact swap every 4 years. 4. KOI 5554.01, the billion-year breeding ground. Life on Earth took about 4 billion years to evolve from simple cells into complex organisms. We often view this timeline as the standard for how long it takes for a civilization to emerge. But KOI 554.01 is a planet that has had much more time. It is roughly 700 light-years away and is estimated to be 6.5 billion years old. That is 2 billion years more than Earth has existed. With a warm average temperature of 80 degrees Fahrenheit and a humid climate, it provides an environment where biological life could thrive and adapt for a much longer period than our own. 2 billion extra years of evolution could result in organisms that have adapted to their environment in ways we can barely imagine. Compared to a world with that much history, humanity's time on Earth is relatively short. 3. Kepler 442b, the mathematical insult. It is easy to assume that Earth is the most perfect possible place for life. We often use our own planet as the baseline of 1.0 to judge everything else. However, when scientists created a mathematical index to measure how well a planet can support life based on its size and energy, Earth scored a 0.829. Kepler 442b scored a 0.836. This planet is slightly larger than Earth, which helps it hold a thicker atmosphere and provides more landmass. It orbits an orange dwarf star, which burns much more steadily than our Sun, and lasts for up to 45 billion years, compared to our Sun's 10 billion. Kepler 442b suggests that Earth might not be the pinnacle of habitability. There are worlds out there that are mathematically better suited for the long-term development of life. 2. The black sun planet, the singularity's edge. Black holes are often viewed as the final destination for matter, with gravity so strong that even light cannot escape. We generally assume planets should stay as far away from them as possible. But astrophysics allows for a planet to orbit a binary system consisting of a normal star and a stellar mass black hole. In this system, the black hole is the dominant force, even though it is only about 60 kilometers wide. From the surface, the star provides light, but you would also see an Einstein ring. a circle of starlight warped and bent by the black hole's gravity into a glowing halo around a dark center. This is the black sun. Because the planet is so close to a massive gravitational source, time would actually move differently there. This is called time dilation. For every year you spend on this planet, your clock would run about 4.7 seconds slower than a clock on Earth. It is a world governed by extreme physics and massive tidal waves. KOI 5715.01, the deep time abyss. On Earth, our time is limited. In about 1 billion years, our sun will become so bright that it will boil our oceans. Our window for life is relatively short. KOI 5715.01 is a super-Earth orbiting an orange dwarf star that can burn steadily for up to 70 billion years. To put that in perspective, the entire universe is only about 13.8 billion years old. This planet could remain habitable for a span of time 5 times longer than the universe has currently existed. With 70 billion years available, life could evolve into forms far beyond our understanding. This could include civilizations that have mastered entire galaxies, harnessing the energy of billions of stars. These worlds show us that the universe operates on scales of time and gravity that make our own existence seem very small. We are on a fragile rock, unaware of what might be developing in the vastness of deep time. If you want to keep staring into the void until it stares back, hit that subscribe button. I'll see you in the next one.